In this video, we'll discuss completing the square, and that's the procedure for solving quadratic equations which have solutions but are not solvable by other methods like the factoring method that we discussed. So for instance, this equation, x squared plus 2x equals 5. If we tried to solve that by factoring, we would go through the usual and we would subtract 5 from both sides, and then we would see that x squared plus 2x minus 5 equals 0. And then we would look for factors of negative 5 that add up to 2. But there are no factors of negative 5 that add up to 2. So you can't factor the resulting polynomial on the left-hand side. However, looking at the graph of y equals x squared plus 2x versus y equals 5, we see that those two graphs intersect each other in two places, and therefore there are two solutions. Okay, the key to completing the square is actually by multiplying out a quantity like x squared plus d over 2. All right, and it seems strange to do that, but just bear with me for a second. So we're going to multiply out this binomial. We're going to square it. So we multiply each term in the first polynomial times each term in the second. And that's going to leave us with x squared plus d over 2x. Think about d as a fixed number. Put that before the variable. Plus another d over 2x plus d over 2 multiplied by itself, which is d over 2 squared. Now, combining the x terms together, which we always have to do when we square out a binomial, we're just going to add the coefficients of x. Right, if it was 2 and 3, you'd get 5x. In this case, it's d over 2 plus d over 2x. And if we take half of something and add it to itself, you get that whole something. So in the middle here, we're ending up with dx. All right, so we get x squared plus dx plus d over 2 quantity squared. All right, and this is where we want to use the identity. All right, this is where this identity comes in. If we have x squared, the coefficient of x squared being 1 there, and we have a number times x, if we add in half of that number, the coefficient of x squared, to our expression or to both sides of our equation, those three resulting terms are a perfect square expression. They're one quantity squared. Okay, that's where we're going to be using this to solve quadratic equations that are not factorable but still have solutions. We're going to complete the square by combining the x squared term and the x term together as one large expression squared, and then we'll be able to apply the square root property as we talked about in a different video. So let's illustrate that here with this equation. So we're first going to subtract 5 from both sides. A little different than factoring. We want to get all the constant terms on one side. All right, we want the coefficient of x squared to be 1, which it is in this example. All right, and then we're going to look at the coefficient of x, which is 6. We're going to divide that by 2. All right, 6 so divided by 2 is giving us 3. All right, we're going to take that number, 3, we're going to square it, and we're going to add it to both sides of our equation. Okay, we can add any number to each side of our equation, but this one is a special one we want to add because that's going to result in factoring those three terms on the left as one large expression, one quantity squared. So we add 3 squared to both sides. Now I'm not squaring 3. We know we could square 3 to get 9, but it's easier just to not square it at this stage. And then we're going to rewrite these terms, these 3 terms on the left, using the identity we just derived. It's going to be one expression squared, and what it is it's x plus 3 all squared. Right, the x comes in, what we added in squared comes in, including its sign. In this case it's positive, and then that equals negative 5. Now let's square out the 3 on the right and get 9. Negative 5 plus 9 is 4. So what we're left with is, all we've done is rewrite our equation, okay, using that identity above, and it's now reading x plus 3 quantity squared equals 4. So it's something squared equals 4. All right, the conclusion is that whatever's inside there, whatever we're squaring, must be plus or minus 2. Has to be. It's the only way you can square to get 4. So the conclusion is now x plus 3 is equal plus or minus 2. And then we're going to solve for x by subtracting 3 from both sides to make our conclusion that x is equal to negative 3 plus or minus 2. Now remember, that's two solutions. So we get x can be negative 3 plus 2, which is negative 1, or x could be negative 3 minus 2, which is negative 5. And those are the two solutions we would get by factoring. All right, so this equation would be solvable by factoring. Okay, the completing the square method is an alternate approach. Okay, but we're going to see it's a more general approach to look at the equation we started with. Okay, clearing this off, x squared plus 2x equals 5, we saw it before, that cannot be solved by factoring. So we need some other technique, and this completing the square method is the most general technique that's going to allow us to always isolate and solve for x whenever a given quadratic equation has a solution or more than one solution. So we take our coefficient of x, we divide by 2. In this case, we get 1. Then we're going to square 1 and add it to each side. Now, squaring 1, not a big deal. We just get 1. But again, I'm going to put that in parentheses, squared, and then on the left, and then add on the 1 squared on the right. And that leaves us with x plus 1 squared in parentheses equals 5 plus 1. So again, the x comes in, what we squared comes in. Don't square it out necessarily. We get x plus 1 quantity squared equals 6. So again, we take the square root of each side now to isolate the x. We're trying to remove the square to get at the x plus 1. So in this case, we get x plus 1 is equal plus or minus the square root of 6. And then subtracting 1 from each side, we get that x is equal to negative 1 plus or minus the square root of 6. And again, that's two solutions there, two real numbered solutions. So let's write them out separately below. We've got negative 1 plus the square root of 6, and then negative 1 minus the square root of 6 separately. Okay, and those are not simple solutions. Even though the original equation had integer coefficients, you're never ever guessing that those are the two answers to the problem. Okay, they involve tough numbers involving square roots. We can approximate these with decimals. We would get, rounding it to 4 places, 1.4495 for the positive solution, and then we would get approximately negative 3.4495, rounding it to 4 places. And that's not an exact solution. It's only an approximation. Whenever we round, we're losing accuracy.